Hello world. That's a famous line from you C programmers out there, and we're going to go low level today. This is Vance Hilderman from AFuzion, and thank you for joining us. Happy morning, Monday afternoon, and a couple of you, I see happy evening there in Asia. As you know, this is the regular monthly AFuzion Tech Training webinar. A lot of technical topics, and it's really a pleasure today. We have a very interesting, very cool presentation from Intel and wolfSSL. I think you know both those companies, but you're going to learn, I promise, things you didn't know before. Security is increasingly important. We all talk about the joy of building application software. Have you ever thought about what goes on before? Oh yeah, there's a lot going on, especially during the boot up. Ooh, okay. So with that, we've got a great presentation for you today. Usual format, 45 to 50 minutes. Start thinking about your questions and write those in, okay? Use the question dialog box, not the chat. We'll try to get to all your questions. If we don't, as usual, we'll send you a personal email. So ask anything, but you know, not personal, it's technical. This is a technical training webinar, okay? With that, let's begin. Folks, boot up, security. If you were a hacker, where would you go? Ooh, the Socratic method, asking questions and teaching by that. Aviation, avionics, but this also applies to automobiles, medical devices, nuclear power plants, right? Aviation uses that ecosystem of DO 178. That's the guideline for software. It's really mandatory. 178 applies to all instructions. That includes boot up, board support package, the BIOS, you know. You have that on your computer that you're watching us on now. Usually there's an RTOS, increasingly so, real-time operating system. You've got application software that gets all the credit and attention, but we've got math libraries, drivers. What's important for DO? All of it. What's important for security? All of it, but you really gotta watch. Ooh, the hardware, boot up, yeah, that's 178C. Now, if it has weight and mass, that's electronics. That is DO254, okay? It applies to everything with complex hardware. What is complex? Hardware that's not simple. What is simple? You got it. Hardware that's not complex, but that means you cannot fully test it. Logic can never be fully tested. Think about that. The probability of hardware software logic error is 1. That's 100%. So we have a development assurance process. 178, that's 71 objectives. Yeah, those 10 categories. If you need information on that, go to the website, download, look at the other videos. But there's an ecosystem here of ARP 4754 that overrides at the system, the aircraft level. We're going to go low level here, hello world, and look at Intel and wolfSSL. Now, think about this. You must have certification of the boot up software because, yes, it's vital, it's key. Now, that ecosystem, we've got the safety assessment, the systems, all these processes, and there's plenty of white papers on our website, free videos, look at those. We're going to focus here on the airborne software, the low-level aspect, but also how that software interfaces with the hardware. Intel makes hardware and software, okay? There's advisory circulars that cover these topics. Now, remember, 178 is software considerations. It allows for waterfall, V model, spiral, PSP, agile, safe agile, a subset. It's developed by industry. We care about money. There's many compromises. It's not a recipe book. It doesn't tell you how to do it. Look at me. There's 71 objectives across 10 process areas, plans, standards, requirements, high level, review them. Review the other documents, design, code integration. These things prevent defects. That's what Intel and wolfSSL bring to the table. But there's 5 more. There's testing, review of tests, configuration management, quality assurance, and certification. These things don't prevent defects. These things find and fix defects. Spend your money preventing with wolfSSL and Intel, then you won't have to fix the defects. It's a discussion flow. It accommodates many different development approaches. Remember lawyers versus software engineers? Folks, we win on this one. That's us, the software engineers. It's really the golden rule. Now, this is AFuzion's opinion. We're the world's largest aviation services company. It's not the FAA EASA's opinion. We teach FAA and EASA, but this is AFuzion's opinion of the ideal, optimum, straight line, most effective certification route. You start with a safety assessment, start your process assurance. That's QA at the system level. You build system requirements. That includes your Intel hardware, your boot up. Then you have plans, standards, checklists. Most companies use the AFuzion templates for that. You develop traceability from safety to system, down to CN, configuration management, and your first stage of involvement, your building plan approval. Now you can build. Here's where we come in with the high-level requirements, overlapping with low-level design architecture. Implement the code. SOI 2, did you do that? There is no validation of software, folks. We don't do V&V because you can't do validation of software. If you don't know why, yeah, look at the other training videos. Then, after all the testing is done, including the boot up, including the Intel hardware, microcode, all those things, those are vital. Then we have a conformity review because you have changes during this process. You won't change your Intel processor, you won't change wolfSSL. They don't need to be changed. We trust them, they're certifiable. We are not sure we trust the developer, that's us. So certification before we flight test, this is what's done. Now, let me introduce my friend and colleague, Gabrielle Davenport from Intel. She's going to give you some great insight into Intel's solution for avionics and the lead into how that integrates and supports the wolfSSL solution for boot up and security. Gabby, it's all yours. You can turn on your video.
Thanks for the introduction, Vance. I highly appreciate it. So to kind of get us started, if Vance, you'd like to show the first slide. Here are just some quick notices and disclaimers that we're required to show. I'm not going to really spend too much time here, but to kind of get into the meat of what we're going to talk about, Vance, if you would like to go to the next slide. So just to get us started, I would like to point out the following. First, more cores cause more complexities and challenges for certification as the number of interference paths rise exponentially with increased core counts. And Intel's multi-core processors offer great performance for a lower core count. This reduces the number of interference paths and in turn certification complexity. So next slide. So just to kind of talk a little bit more about our processors here, you know, Intel hired a FAA DER consultant, AFuzion, to compare the industrial standards they were built for against the avionics standards mentioned in DO-178C/254. With this assistance, we took the data that we utilized in the automotive and industrial domains and augmented that data to assist avionics customers. So Intel provides the data that you would need to integrate into your certification packages based off of each processor. And I would also like to point out that Intel processors deliver significant advantages for avionics. These use conditions include long life of parts, 7 to 15 years for some parts, support for extended temperature ranges, and high performance in a single package. This offers to avionics customers aviation customers processors that are flexible in size, weight, and package. So next slide, please. So I want to introduce here a part that's going to be discussed called the Core i7-1186 GRE. So it supports processing power needs, and furthermore, to improve determinism for avionics use cases, this processor comes with thermal throttle disabled. And you know, just to kind of provide a little context about what that means, if you're not familiar with that. So generally speaking, in a controlled temperature, processors can dial back performance to keep the part from overheating. However, this is a no-go with avionics, and when we're looking for that increased determinism. As you know, many systems have multiple processors and have other ways of managing temperature. So we as Intel offer this solution where you can manage the temperature of the part, and you do not have to worry about the part dialing back performance based off of its temperature. But to kind of get into some of the advantages here besides thermal throttle, we also offer the airworthiness evidence package, which can help accelerate your time to certification. Normally, we do not offer the data included in this package to customers. It is under NDA, and we license this data, but this data includes, items such as failure mode effects analysis and diagnostic analysis. There's a lot of reliability data, sightings reports on the processors, and other information that can really assist in the certification process. We also offer an AMC 20-193 guide, which provides guidance on how to configure the parts to further limit interference between cores. And I would just like to point out that the AEP package, the Airworthiness Evidence Package, is a foundation on which a complete end-to-end certifiable system can be built. And this enables you to build your certification packages on the full software stack, which all layer up to provide the foundation for your applications. And again, we do offer this for the 1186 GRE, as we created this part with our Avionics customers in mind. But to get to the next slide here, getting into boot, the focus of this webinar, I would like to talk about the Intel Avionics Pre-OS checker. So for the 1186 GRE, the Intel Avionics Pre-OS checker can be integrated into the boot sequence of Intel's Slim bootloader. Prior to the launch of the operating system, the Pre-OS checker verifies the platform configuration as part of the boot sequence following the bootloader execution. The Pre-OS checker can work with an external safety monitor to validate the configuration of the silicon prior to the RTOS. If a failure is identified, the platform will move into a safe state and it will not be allowed to run. So to assist with DAL-A certification, we include data that is relevant to DO-178C. We would like to point out that this is certifiable to DAL-A, and for lower level certifications, the requirements may be relaxed. We provide everything needed to integrate it into the software stack and certification artifacts. Sorry, I thought I had to sneeze there. This is available for license late next year. And with that, the next slide. So if you would like to discuss more about how Intel enables airworthiness certification, more about any of our products, the Pre-OS checker, the processor, or anything we discussed, this is the contact of myself, Gabby Davenport, product marketing engineer, as well as Deborah Aubrey, who's a great resource, our technical product marketing manager. And with that, I would like to hand it back to Vance, who's probably going to hand it over to wolfSSL.
Fantastic, Gabby, that was terrific. And folks, you all know about the Intel Airworthiness Package. If you're not familiar with that, guess what? You can go to the AFuzion website or YouTube and download that free training video from Intel that describes that terrific product. And the new Pre-OS checker coming out next year, as Gabby mentioned, is really terrific as well. So right now, we're going to turn it over to wolfSSL. My colleague, Mr. Chris Conlon, is going to describe for you all the cool stuff that they're doing and really go to deep, low level. You're going to get a great education here on wolfSSL security and the boot up process. Chris, it's all yours.
Thanks, Vance and Gabby. Hey, everybody. Like Vance said, my name is Chris Conlon. I'm a engineering manager here at wolfSSL, based in Bozeman, Montana. On the call with me today, I've got two of our senior engineers, Daniela and Marco. So when we get towards the end, if you have any technical questions about wolfBoot, they've been key authors of our wolfBoot product. So today we're going to be talking about DO-178C secure boot in the context of our secure bootloader called wolfBoot. Just a couple of quick slides as far as an intro to wolfSSL goes. Some of you may have heard of us. We might be new to some of you as well. So wolfSSL was founded in Bozeman, Montana in 2004. We've grown every year since then. Now we have over 2,000 commercial customers using us, securing somewhere around 2 billion active endpoints at any one time on the internet. We really focus on three main areas: securing data at rest, just using cryptography, securing data in transit. This can be done with SSL and TLS, SSH, typically run over TCP/IP, but really could be over any number of transport mediums. We have people doing TLS over things like Bluetooth and serial. So we have a flexible manner to let you plug in the transport there. And then the third main category is doing secure boot and firmware updates. So you mix together a secure transport medium like TLS or SSH or secure MQTT, and mix that together with the crypto primitives and the secure boot to get things started. So there, our main goal is to prevent your devices from being flashed with malicious firmware. This is our current product lineup. So our primary products are wolfSSL and wolfCrypt, our SSL and TLS library, and our underlying cryptography library. So these are all products we've written from scratch. They're all written in C with some assembly for performance optimizations. wolfCrypt has a couple validated and certified versions available for FIPS 140-2 and soon to be 140-3, and also our D178 certification. We have an MQTT client library, a SSH library called wolfSSH, a TPM 2.0 library called wolfTPM. What we're focusing on today primarily is wolfBoot, our secure bootloader. We do have a embedded intrusion detection and prevention system called wolfSentry. And we have Daniel Stenberg, who's the author of curl, on board as a wolfSSL engineer. So we do offer support and consulting around curl. We have a version of curl that's pared down, meant for resource-constrained devices, and we call that tiny curl. All those primary products are written in C, so we do have users that want to use us from other languages. We have got a wrapper for Java, C#, Python, JavaScript, and Go. And all of our products are dual license, so we're open source under GPL v2 or v3, and then we do license the same code bases under a commercial license for those that can't tolerate the GPL license. This makes it really nice to download and get prototyping. Clone it from GitHub, download it from our website, see if it runs in your environment, do some benchmarking or anything you need to do for evaluation. So moving on to secure boot, first of all, the big question is why secure boot? So secure boot prevents running unauthorized software on your device. A cryptographic signature is attached to the firmware image, and then the bootloader will verify that image before it boots into the system. And so the bootloader essentially refuses to run non-authentic code, which is a great thing. Now, if we can look at safety and how that compares to security, top class or high quality software safety does not necessarily imply security or vice versa. So security software must also be safe, and that's where things like D178C, no dynamic memory allocations, having a predictable execution flow, all come into the picture. Also, safe code is not necessarily secure by itself. So safe code must still follow cybersecurity guidelines and standards. The ancient mentality is if it ain't broken, don't fix it. Well, the new paradigm based on vulnerability management is something along the lines of, when something breaks, be prepared to fix it. So when we started in the beginning of authoring our wolfBoot product, we went out looking for, what standards are there for secure boot and secure firmware updates. And at that time, the IETF suit group was working on an internet draft called a firmware update architecture for Internet of Things. This did become finalized in April of 2021 as RFC 9019. Just a couple quotes from the document there to tell you a little bit about what it says. Remote firmware transfer is implemented in the application as it is specific to the connectivity technology in use. And the bootloader must provide a secure mechanism based on asymmetric crypto to verify the authenticity and integrity of the firmware. And so there's a number of requirements in and encapsulated in this RFC. You can see some of those listed in the box here on the right-hand side of the slide. And we did follow those requirements as we were implementing wolfBoot. So onto wolfBoot, an overview, design of our bootloader, and how we can be used on 11th generation Intel Core processors. So when we started the project, some of our project goals are listed here. So we wanted it to be portable all the way from bare metal, small, low-level systems up to larger systems. We wanted to verify the integrity of the system using SHA-2 or SHA-3. We wanted to verify the authenticity of the firmware image using public key-based cryptography. We wanted the code base to be small, which also meant it was going to be easy to audit. We wanted to have memory safety to help reduce the attack surface. meaning no dynamic memory use. We wanted to have interrupts disabled at all times, which gave us a statically predictable execution flow. And like you saw in the previous slide, we were going to base it on the RFC 9019. So for portability, wolfBoot is written in C. That means you can use it on a bare metal environment. You can also use it all the way up to a larger system. We can integrate into everything from bare metal to a bunch of RTOSs or just a full-fledged OS. We support multi-boot, ELF, and Linux support. We have an abstracted HAL design for CPU speed and flash. This can make it a lot quicker to port wolfBoot between targets. And it has a very small footprint, so it makes it easy to audit and able to run on, like I said, low-level devices. So for this presentation, we'd like to highlight wolfBoot's support for 11th generation Intel Core i7 processors. This is a fairly new addition for us, which we're wrapping up now, and we're also taking this through a DO-178Z certification, which we'll have a couple of slides here to share some more details on that with you. So on the Intel Core i7 platform, wolfBoot can essentially run inside the UEFI environment and then load and verify other EFI applications. And in addition to the Intel Core processors, we do support a number of other popular architectures, which you can see here on the bottom of the slide. For chain of trust integration, so wolfBoot acts as a standalone bootloader using a single trust anchor. And it can integrate into an existing secure boot chain if you have that available or already existing in your product. And it can come into the picture to provide authentication of the firmware image using public key cryptography. wolfBoot can also be compiled as a library if you need to integrate with existing bootloader solutions. Now at boot time, we do authenticate the firmware. We use public key crypto using RSA or ECDSA or ED28519 or 448. By default, we use wolfCrypt, our cryptography library, but we can easily use an external HSM or secure element if you have that available. A lot of times, having the hardware accelerated crypto can give you performance improvements and also help reduce the code size of the bootloader and the crypto library. wolfBoot does support TPM 2.0 devices. This is primarily for storing keys in the TPM device. Some of those do have cryptography operations as well. So for updates of the bootloader, wolfBoot can update itself if that's something you need to do. Oftentimes that's used if you need to roll and update the keys, the public key that's encapsulated in the bootloader. For key management and provisioning, we try to make this as easy as possible. So we ship some C tools with wolfBoot that help you with key management. These are easy to integrate into your backend server side, especially if you've got an existing signing infrastructure in place. You can put these in place to help append the right signature and do some of those steps that are necessary with the firmware image. You can also associate multiple public keys with different update partitions. A big advantage of wolfBoot and wolfCrypt is that it's actively maintained and supported by our team. So we're working on this full time, adding features, cool new things, bug fixes, improvements. And then we also have support packages available. So you can purchase the support package from wolfSSL all the way up to the 24/7 level, where if something goes wrong, you can pick up the phone or send us an email and we'll get your problems squared away quickly. Being open source, we do have a number of update examples available. So you can see how wolfBoot could be used on targets, pull them down, try them out before you commit to a commercial license engagement. So I mentioned by default, wolfBoot uses wolfCrypt underneath for cryptography operations. And we use these in a couple of primary key areas. So we use public key algorithms for verifying the image. We can use ECC, RSA, ED25519 or ED448. We've also got some experimental post-quantum crypto that we're playing with internally. We use message digest algorithms like SHA-2256, SHA-2 and SHA-3 And then if you're doing encrypted updates, you can use AES counter or CHA-20 poly 1305. Now, wolfCrypt itself can help you meet your validation requirements at the crypto level. So we've taken wolfCrypt through DO-178C up to the DAL-A level, and that's for the crypto primitives. And then we've also FIPS validated wolfCrypt. So we've done two 140-2 certificates. We do currently have a couple 140-3 certificates in the process. And so those can be helpful if you're targeting DoD or government type applications. And so by default, wolfBoot uses wolfcrypt, but we can use hardware crypto elements, platform-specific assembly. You'll see in a few slides how we can take advantage of some of the things that Intel offers on their platforms to help with performance. For wolfcrypt's DO178C DAL-A certification, like I mentioned, we have certified the crypto primitives that would be required for secure boot, firmware updates, secure transport. You can see the algorithms and key lengths that we've certified on this slide. And typically, when we work with a customer, one of the first steps we'll do is go through a requirements identification phase and slim down the code so that we minimize the lines of code that you need for your specific use case. And so that helps reduce the attack surface. It helps reduce the cost of the certification process. And then, we're pretty excited actually to announce that we're taking wolfBoot itself and wolfTPM through the DO178C certification process right now. And so they're being certified up to the DAL-A level as well. And so this will likely be, potentially the only secure bootloader TPM crypto combination out there that's completely DO178C certified. And all of this is going to be running on Intel 11th generation Core i7 platforms, at least as a start. So for key management, like I mentioned, we like to make this easy for you. So up front, a key pair is generated once. The private key will stay on the server side, typically is never shared. That might be held in an HSM or somewhere secure. The public key is stored on the target and is accessible by the bootloader itself. That's what's used to verify the image. We don't have a revocation mechanism provided. So if your private key gets compromised, you'll need to rotate or update the public key on the device, which will most commonly require an update of the bootloader itself. And the security really of this system is going to depend on the security of your private key on the server side. So that's very important to keep private and secure. Some of our tools that we ship with wolfBoot that make it easier to use this as a whole system. One of them is a sign tool that attaches a manifest header to the image. So this manifest is used to validate the integrity and the authenticity of the image. It also puts the firmware version into the verified payload. And so that can't be altered and gives you some extra checks you can do at verification time. Now, wolfBoot does rely on a trust anchor on the device to embed the public keys used to verify the signature. So, it's best to get a definition for things like trust anchor because people might have different things in their minds as far as what that means. So here we're reaching out to the RFC 6024, and this has a definition of trust anchor for us. So bear with me, I'm just going to read the quote here. A trust anchor represents an authoritative entity via a public key and associated data. So the public key is used to verify digital signatures, and the associated data is used to constrain the types of information for which the trust anchor is authoritative. Now you have the trust anchor. The trust anchor store is a set of one or more trust anchors stored in a device. So if we take that trust anchor store definition and we look at how does that apply to a secure bootloader, well, there's where we can come into play with the RFC 9019, which says a trust anchor store must resist modification against unauthorized insertion, deletion, and modification. So for our bootloader, we have a couple options for trust anchors and trust anchor stores. The first one being flash readout protections, which will just prevent the key or the trust anchor from being read out. This is sufficiently secure for most cases, but it's not going to prevent against all hardware attacks. Kind of the next step in security is having a secure element or TPM or using Intel BootGuard to implement the trust anchor for you. You might also see an out-of-bound trusted provisioning authority or TPA come into play where a manufacturer might install trust anchors into the devices at manufacturing time. That might be done with a TPM or the secure element or in some other manner. So for interaction with the TPM, wolfBoot has pretty much complete access to the TPM through wolfTPM. So you've got some available options now that you can use the full TPM functionality You can offload crypto operations to the TPM. You can access the keys stored in there as a key store. You can seal and unseal arbitrary keys and secrets based on system measurement. Or you can use password protected keys inside of the TPM. So these are all beneficial for various use cases or requirements you might have on your end. A couple advanced features of wolfBoot. So fail-safe countermeasures. This is essentially preventing the $1 million brick. We all know that avionics especially is very expensive, and you don't want your plane or your avionics device to turn into an unresponsive brick. So what can we do to help prevent that? So we have a predictable flow of our software with no dynamic memory use. So this means you're not going to run into stack and heap collisions. We'll have interrupt requests turned off, and you'll have a compile time defined behavior. With wolfBoot, for our firmware updates, we do have a power failure safe swap operation. So this means if the power is interrupted at any time in your update cycle, the device can reboot and successfully resume where it left off. And wolfBoot does this by keeping track of the completed sectors that it updates. And so when your device is cut off or reset unexpectedly, we can know exactly where to resume that process. We can also roll back to a previous version. So once wolfBoot is booted into a new image, it gives the application the opportunity to confirm that looks okay. If it doesn't, wolfBoot will just roll it back to the previous image. Delta updates are a nice feature if you're doing firmware updates and you don't want to transfer the whole entire image. It's essentially a binary patch between two versions, so it can really help reduce your transfer time and size being transferred there. We also have some side channel and glitch attack mitigations. Things can protect against things like voltage and clock fault injections, but they do tend to be fairly architecture specific. So now that you've got an idea on what wolfBoot is, let's show you how you can use wolfBoot on 11th generation Intel Core processors to get a better and more secure and more performant complete solution. So when we were porting wolfBoot to Intel Core processors, we did need to use the Intel FSP or firmware support package. So this is responsible for initializing the memory controller, preparing the memory sections, initializing the silicon, and it does allow us kind of a complete and easy solution to initialize a lot of these things. We needed to use and interact with Intel BootGuard, so this provided root of trust for verification and also root of measurement for the boot process. And then we needed to work with PCI and peripheral initialization, which did require bootloader support for dynamic device enumeration. Some requirements that we needed to work with when porting over to the 11th gen Intel Core processors was verification of all the components used in the boot process. So that included the FSP, the binaries, the configurations. We needed to interact with the AHCI and SATA driver for secure disk unlocking. So in this specific customer use case, we were using a TPM for sealing and unsealing a disk secret, which could then be used to decrypt the operating system image. We needed PCI dynamic enumeration with runtime discovery. We know we needed to use Intel BootGuard to implement the root of trust and root of measurement. And we knew we needed to support multiple OS protocols and formats. Here's a diagram that shows you the wolfBoot boot flow on this Intel platform. So the green image is signed with Intel tools, and that's verified by Intel BootGuard. So execution starts on the top left there with the reset vector. wolfBoot stage 1 is the first thing that happens. That loads and executes the Intel FSP. The FSP initializes memory. We verify the last FSP section, which contains the initialization of the silicon. And then that verifies wolfBoot stage 2. wolfBoot stage 2 then goes on to select the image to boot, verifies the authenticity of the image, and then loads and stages the operating system. So benefits of using wolfBoot on an 11th gen Intel Core processor, it could include performance. So we'll see here in a couple slides, you can take advantage of Intel AVX2 and Intel AES-NI to accelerate some of the crypto operations. Bringing in a fully DO-178C certified secure boot solution can be greatly beneficial depending on your requirements. And then this also gives you the ability to integrate special features into the boot sequence. And this was also one of the key requirements for our customer in our most recent project, was that we were replacing the Intel Slim bootloader with wolfBoot so that we could inject the ability to seal and unseal a password from a TPM 2.0 module, and then go on to unlock a SATA drive and boot the OS image. So that was functionality that wasn't existing in Intel Slim bootloader, but by replacing that with wolfBoot, we can easily make that happen. So for performance improvements, you can see these in firmware integrity checks and firmware encryption and decryption through the use of Intel AVX2 and AES-NI. AVX2 accelerates SHA-256 and SHA-384. And if you're using wolfCrypt, you can enable this support at build time. And so based on our testing on this specific Intel platform, users can see 63 to 83% improvement in throughput of SHA-2 and a 38 to 44% reduction in cycles per byte of data processed. If you're using Intel AES-NI, so this is going to accelerate AES operations. There you can see throughput speeds increase by 490 to 3,488%, and cycles per byte used decrease 83 to 97%. And so the ranges here, depending on what operation is being done, and these are just benchmarking the crypto primitives themselves. So a couple tables for your reference. Here's the one showing throughput improvement with those algorithms. And this is the table showing reduction in cycles per byte. We've also got some system configuration details on the bottom of the slide to let you know what type of platform we were using for these benchmarks. Now to replace Intel Slim Boot, I guess a quick intro to Intel Slim Boot, if you're not familiar with that. So it's designed to be small, fast, secure, extensible, and configurable. It also uses the Intel firmware support package for initializing Intel platforms. It uses a linear staged boot flow, which you can see kind of a rough breakdown of the boot process in that table on the bottom of this slide. And then it can boot a UEFI payload. So why replace Intel Slim Boot? It might work just fine for your application, but there are a couple of use cases that you might be looking for something different. If you have a requirement for a D178C certified crypto library and or a bootloader combination, if you have a requirement for FIPS, 148-2 or 148-3, mainly meaning if you're selling into the DoD or government areas. If you have a requirement to use CAVP or ACVP validated cryptography, sometimes, so CAVP is just an algorithm certificate, and sometimes that can be a requirement leading into a higher level certification like common criteria. If you have a desire to use hardware-based crypto for performance improvements or code size reductions or using platform-specific assembly, if you want to use a secure key storage like a TPM 2.0 module, or if you want to put some custom steps into your boot process. A couple of modifications that we needed to do when we replaced Intel Slim Boot, these were done to wolfBoot. We added support for calling the Intel FSP microcode APIs, added a stage 1 loader for memory initialization, added drivers for Watchdog, UART, and SPY, supported multiple signing partitions, multi-boot, and ELF32, added support for calling the power on built-in tests, acronyms PBIT, support for calling a TPM based root of trust and measured boot, and then lastly, the support for the unlocking of that SATA drive. So that kind of gives you the overview of, wolfBoot, how we got that to work on the Intel platform, some of the advantages and reasons you might want to do that. So, hopefully you can take some of this information and go on to help you secure your avionics boot processes on, Intel platforms, whether that be 11th generation Intel Core i7 or a related platform using wolfBoot. That can help you provide a safe operation and secure system. You can build on the kind of strong aviation and avionics foundations that wolfSSL and Intel have. We might be able to lend some feedback on your designs or what you're thinking of integrating. We can help you meet DO-178C and other certification requirements, optimize performance and memory use, layer on added security with secure key storage and TPM 2.0 modules. And maybe the most important thing is, protect your boot process and your device from becoming the quote unquote $1 million brick. So with that, I'm going to hand it back over to Vance to take us out and lead us into Q&A.
Chris, that was really terrific. And Gabby also, what a wealth of information, folks. We went low level, more than hello world. All UC programmers know that this time. So terrific information there. You learned about the Intel Airworthiness Evidence Package, the pre-OS checker, the mandate to really consider cybersecurity. DO326, and we didn't go into details. We have separate training videos on that, white papers, look at that. But DO326 or ED202A in Europe is now mandatory. Aircraft, systems, software, it's everything, okay? During development and during operations. So it's really vital that we start considering this guideline of cybersecurity, okay? It's mandatory. So thanks so much, Chris and Gabby. Folks, right now, we're gonna switch over to the Q&A session, kind of like we mentioned, right? We've got some good questions, so you can still add your questions. And it looks like we've got about 15 minutes for Q&A, so we might be able to get to all your questions, okay? Timothy asks a question here. When considering, Timothy, I'm gonna preserve everybody's last names. We got GDPR and everything to worry about, okay? And I don't know you, but Timothy asks, when considering cybersecurity solutions, one thing to consider is portability of solutions across multiple different families of processors. Great idea, Timothy. I see that wolfSSL says the solutions are written with a HAL, H-A-L. How portable, Chris, this is gonna be a question for you, Mr. Conlon. Tim's questions are, how portable are solutions from different families of Intel processors to things like Texas Instruments? Ooh, shall we mention that one? Digital signal processors, DSPs. And then how flexible is this product line for secure boot, as well as the data at rest in transit? So ultimately, how can customers, if I paraphrase, be better enabled optimally to move across silicon baselines within and without the Intel family? Chris, you got some insights, and then maybe that's a good question for Gabby or the Intel team as well. Go ahead.
Yeah, I can definitely answer this. I do want to give Daniela the first chance, though, if you're here, Daniela.
Sure. Yeah, of course. Yeah. So yeah, as you noticed already, so the HAL is an abstraction layer for porting to different platforms. We do already support several architectures, and within that same architecture, it usually boils down to just providing access to non-volatile memories that store the images that have to be verified. Of course, porting to a new platform that outside the architectures that we support takes a little bit more effort from our side, but we do already, I think we support about 7 or 8 different architectures besides Intel 64 and 32-bit, and of course most of the most common ones on the market.
Thank you very much. That's a great clarification. And I wonder if our Intel team, Gabby, Deborah, Shizuka, if there's anything you might want to add concerning portability within Intel family line, pertaining perhaps to pre-OS checker, perhaps to Intel Airworthiness Evidence Package.
Hi, so this is Debbie Aubrey. I think Gabby mentioned at the top or at the end of her presentation, I'm the market development manager for our federal and aerospace business unit. So one of the strengths of Intel processors is that from one generation to the next, our instruction set is very stable. So, especially as it relates to the pre-OS checker, our architectures are very stable and backwards compatible. So what you find is, once we have the pre-OS checker developed and released for the Tire Lake platform, that it's actually going to be a fairly light lift moving forward from a porting perspective to bring that to our next generation silicon that we're going to that we will be releasing.
Very good. Thank you, Deb. Excellent. We have a question. This one's an Intel related question, I think, from Michael. Michael asks, we're increasingly seeing Intel on the aviation front, something we didn't see 20 or 30 years ago. Is aviation avionics an area that Intel's really looking to get more and more involved with, as it certainly appears that way? Deb, you want to?
Yes, so,
Please.
Oh, sorry, I didn't mean to cut you off there, Vance. But yes, no, Intel definitely is making significant investments with respect to development that's targeted specifically at our avionics customers. You know, we talked today about how we're offering avionics specific SKUs for our core products such as the 1186 GRE, as well as we're currently offering a SKU as well for our Raptor Lake part. We also, as we discussed, are offering the airworthiness evidence package, and we offer this for several of our processors, not just our core processors. We also have offerings for our Atom and Xeon processors as well. As you know, on top of that too, we have our Intel Avionics Pre-OS Checker. Also to kind of say here that, you know, Intel is very interested in making substantial investments in products that we believe that our avionics customers will enjoy and utilize.
Fantastic. Thank you very much, Gabby. And wolfSSL team, got a question from Elizabeth for you. Cybersecurity is increasingly important, as was mentioned in the webinar, and it requires both during development of products and during deployment. Can you tell us a little bit, wolfSSL, about how your solution works towards that DO326 compliance and cybersecurity from a bootloading standpoint? Just a tad more information.
Yeah, Daniela, do you have an answer for that one?
Not specifically for DO326, but in general, we have developed wolfBoot, keeping in mind different type of provisioning and interaction with external components that might be keeping our keys safe and helping us, for instance, provision each single target there. And it has been improved during this port because we were able to integrate with the Intel boot guard in quite a smooth procedure and chain load different ranks of keys in the process. So for the more complex use cases, and of course the existing tools from Intel helped us a lot for doing this in this specific scenario. But we have seen also other customers using us with external key provisioning system as a service, or directly related to the manufacturer that is pre-provisioning different keys on different targets, etc. So there is a lot of flexibility in integrating that with our host side tools to sign and optionally encrypt the payload that has to be verified on the target.
Thanks, Daniel. You folks are giving terrific detailed answers. Love that. The next question from Juan over in Spain asks, why bootloading for certification? It just executes during power up before the airplane takes off. Why would it need to be certified? Ooh, great question. Let me go ahead and answer that one if I could. So yes, it's true. It executes while we're on the ground. I'm a pilot and that's all good. But when I'm flying, I've got 2 seconds for a go, no-go decision. Okay, V0, V1, takeoff, roll. Okay, that's not the time to find a defect. If there's a defect in the bootloader, I don't really see it. All of you powered up your Apple or your Microsoft Windows machine this morning, and Microsoft's not certified either as Apple, and these are fine products now, you know. But folks, consider when you booted up, you executed hundreds of thousands of lines of code. That's why it took a few seconds to turn on your iPhone, your computer, okay? Did you find the defects? No. Is it possible that you actually executed a few dozen, hundreds, thousands, millions of Apple, Microsoft software defects? You don't know, okay? You've all seen that blue screen, now black screen of death, or little funkies on your Apple, right, when you update. So bootloading is really important, okay? That's why it has to be certified. But now, let's think. When you reset, imagine I'm flying my airplane late at night, coming in for a landing, and I'm landing in Sedona, Arizona, private airport, fairly tricky. And trust me, that's where I'm broadcasting from right now, northern Arizona, Sedona. Tricky airport to land, okay? Top of the plateau, think of large aircraft carrier. That's not the time. Ooh, what happens when you reboot? Ooh, you re-execute the bootloader. Oh, it depends. Hard reboot? Absolutely. So, folks, if there's a defect there, it has to be certified. Got it? Hope that makes sense. Adrian asked a question. This is an Intel question. Do we have an Intel multi-core processor that's DAL-A certified for avionics? If so, can you explain which processor that is?
Great. So we don't have any certified processors. So right now, we're mainly focused on selling COTS parts that are in accordance with AMC 20-152A. However, we're always happy to work with customers who would like to develop more targeted multi-core processor solutions for avionics that incorporates our COTS IP blocks, as well as, we do offer semi-custom silicon offerings. But the short answer is no. We're specifically focused on making sure our COTS products are marketable in accordance with AMC 21-52A. So therefore, we don't have any certified processors.
Great answer. And folks, remember, AC 2152A or AMC 2152A over in Europe, that's the fifth and final, well, we think, until the next final interpretation of DO254. It's not like 178, okay? 178 is self-contained. There's 4 versions. You're using 178C now, all new products. You don't ever have to open 178B, the 3rd version, unless you have a legacy product. Remember, 178, 1980. 178A, a few years later. 178B, 8 years later. 178C, ooh, 15 years. Yeah, okay. So, yeah, it's self-contained. DO254 is not. We had 254, additive. CAS 27, CAS 30, okay? Additive. AC 2152, additive. EASA. SWCEH, Software Complex Electronics Hardware Certification Memo number 1. Okay, CM number 1, highly important, additive. Got it? And now AMC, AC 2152A in USA, AMC 2152A in Europe. Yeah, which one do you use? All of them, they're additive. Okay, and Intel's compliant with that. Got it? Okay, folks, I think we have gone through all your questions. That's terrific. All right. Well, I'd really like to thank Gabby, Chris, all the Intel team, all the wolfSSL team, all your preparation for this. Gabby, Chris, any final words for our audience before we wish them a happy rest of morning, afternoon, evening, night?
Just thanks for coming. I think this goes for all of us. Feel free to reach out if you have any questions at all about any of the things that we discussed. We would be more than happy to speak to you guys. I think all of our contact information is visible on the slides right now. But thanks for giving us a little bit of your time wherever you are in the world, morning, afternoon, night. That's all on the Intel side. And Chris, you got anything?
Yeah, likewise. Thanks everybody for attending. Like Gabby said, shoot us an email if you need to have any follow-up questions, or we're here for you.
Fantastic. Thanks, folks. We'll see you next month for the next session. Have a great day. Bye-bye. Safe skies always.